Good afternoon. My name is Sanjoy Maity. I'm the CEO of AMI. And what we do today is we will talk about the open source of open foundational technologies that AMI provides. I have a guest speaker with me today, Mohan Kumar, who is an Intel fellow at the Intel Data Center and Cloud, as well as the AI development. So today's agenda is a general open source. Why we are doing open source, we probably already know, but there is some implication about the foundational firmware that we build. So what do we do at AMI? We build foundational firmware, which is boot firmware, manageability firmware, and today I'll be also talking about security firmware. And then the next thing is there is some problem with the, I think this is not, sorry, my slides are, the slides are not progressing here. Yep. Okay. So now then I will be talking about some problem statement. Open source is very good, but there are some issues that we'll be talking about and how AMI can address those issues, right? And the third one is, what is the solution should be for the community? We are building a community. Today's my topic is, how can we build a robust ecosystem using the open source? And the final one is AMI's commitment about the open source. We embraced open source. What is our commitment and what is the contributions that we have done in the past and we are committed to do in the future? Saying that, we all know open source today, that every organization is using open source, but it is more than that. Today my presentation and whatever AMI is doing, I will target three things. One is open source brings security because the code is visible to everybody. Everybody sees the open source in the industry. They fix the issues that open source has and continuously improve that open source. So it brings inherently some security to all the organizations. Second thing is a freedom. Freedom means you own the source code, you own the system from beginning to the end. And also it gives you freedom to do anything, whatever you want with the code for your product. And third one is innovation. Open source enable you to innovate with your own hardware, with your own platform, with your own product. So how do you do that? So my presentation will be to show that how AMI is bringing open source in a package for the ecosystem to enable the ecosystem, to enable everybody to do these three things. So the overall goal of the open source foundational firmware, because AMI builds the foundational firmware, so particularly for that, we need a very robust ecosystem, because the ecosystem players should be the hardware manufacturer, the ISVs, CPU manufacturer, and so on and so forth. So we should have a very robust ecosystem. Second thing is robust platform security. Whenever we are talking about ecosystem and open source, the firmware will be touched by many parties, many different entities. So there has to be a good story about the platform security. Third one is the robust quality control. Open source, good, visible, people are contributing, we are making an ecosystem, we are making a community, but that piece of software or firmware must provide the highest level of the quality. Next one is a good, robust supply chain. Because the firmware is developed in multiple countries, multiple places, multiple engineering teams, collaborating together, so it should provide a good bit of supply chain security, including software bill of materials. And the last one, not the least, is the robust support model. Open source is available, you make a product out of it, and then you have to deliver to your customer. Not only that, you have to support that product for not 5 years, 10 years, sometimes 15 years, depending on the sectors, depending on the segments. So that is also very important. So what is the problem statement? Very simple. Open source also tends to be fragmented whenever it is implemented by multiple companies in the ecosystem. If I pull open source and if I develop my own product, it's not going to the community, and all the patches, all the updates, all the bug fixes, everything stays with different companies, then it becomes fragmented. Nobody enjoys the benefit of open source. It defeats its purpose. That is one issue that we see. And overall platform level security and resilience. If something happens with the platform level firmware or the foundational firmware that we are talking about, how do we protect, detect, and recover? How the resilience comes into the picture. That is very important. And third one is lack of consistent long-term support. It has to be consistent, that the way that today's proprietary software provides the support for a long term, open source should also provide the exact same way. So these are the three things that we'll be talking about today. So this slide, we see what are the necessary ingredients about the foundational firmware or foundational technologies that we are talking about. Left-hand side is the open system firmware, which is the essential boot firmware for any platform. Here we see there are two sets of open source components. Left-hand side are we call platform orchestration components, which are U-boot, could be Slim boot, could be core boot, could be DK2. We are very familiar with these names. They are used for creating the bootloader's platform orchestration portion. And the top level you see, there are OS payloads, which could be UEFI, Linux boot, and Grub, this kind of things. So what we see is a varieties of combinations of platform orchestration and the OS payload that finally builds your actual firmware. So it's getting complicated and having a lot of parameters where it can be fragmented, it can have a security problem. And so what are the stack? First of all, there has to be an abstraction, which we heard from Intel today previously, that there is an FSP, which is the abstracted silicon enablement code. On top of that, there is a actual silicon enablement code, which is the orchestration comes into the picture. Then we create the platform orchestration, and then we create the actual OS payload. And right-hand side, if you see, these are the ingredients for making a manageability firmware. There are different SoCs. The most important one is ASPEED, and then Novoton is also there. There are two different SoCs are available. There are SoC abstraction layer, application abstraction layer, and there are some IPs that we build on top of it. All are based on OpenBMC, the Linux Foundation OpenBMC. To create a successful product, these are the necessary ingredients. And when we are talking about the necessary ingredients, I should talk about the recipe. So the success recipe could be that when we are building the product, we are talking about a build orchestrator. So first of all, there are two things in the middle. You see, the AMI will provide, which is something like a kickstart, where you can build a product from our contributions. And then if you want to get into a higher level of integration and support and everything, then we provide something called build orchestrator, where we can take any type of platform orchestration code, module, and the OS payload, and we can create very flexibly an open system firmware. Same goes with the BMC side. Based on OpenBMC, we could build varieties of flavor using the build orchestrator. So this is a success recipe that we are bringing to the open community. So what is our commitment? Last year, we presented that, okay, we contributed Aptio Open Edition, our BIOS or bootloader version, and a MegaRack Open Edition, which is the OpenBMC-based open source BMC firmware. This year, continuing that, we would like to announce that we worked with, in collaboration with Intel, and we standardized the OpenBMC-based MegaRack OE stack for the ecosystem, and we are announcing that that is available today. And saying that, please help me welcoming Mohan Kumar, the Intel Fellow of Intel Cloud Data Center, to say a few words about our collaboration.
Thank you, Sanjoy. Thank you for having me, Sanjoy. It's a great pleasure here to see this result of the work that we've been doing together. I wanted to take you through the journey of how this all came about, right? So Linux, OpenBMC is a Linux Foundation project, right? It's an open, based on the open firmware principles. What you see on the top side of the graph is basically the trees that we have for Linux Foundation, so upstream repo, where all the code is kept. And then we have branched off of that to develop some, speed up the development for some of the stuff that we do at the system level. And from there, so essentially, so we have contributions that are going from AMI's base repository into the Linux open repo, up and down, right, both ways. And similarly, Intel also have their own, our own repositories, and these are for primarily supporting our platform and our value-added features that are part of our silicon, right? So those are the two things that are specific to Intel. So those are basically in the Intel repository. But what we do is to essentially both the Linux OpenBMC and the Intel repositories feed into what Sanjoy and his team build into what's the AMI's base open edition model. And that combined solution is essentially what goes back up and what Sanjoy is contributing today as part of the AMI Open Edition for OCP, so it's available to everyone. So essentially and the NDA features essentially go into an AMI's, another repository for add-on features, and then the whole model has got, of course, your support built on top of it. So what you start with is open source, features and the OCP's platform recipes all put together, and now you have a solution that you can apply to, I believe, already 2 platforms that take advantage of this, and there is more coming along the way. And we thank AMI very much for getting us here, both on behalf of Intel and on behalf of OCP.
Thank you. Thank you, Mohan.
Thank you.
Thank you. So we have seen that, as I mentioned in the beginning, that we are trying to solve these 3 issues that is happening, we see in the open source. So at the end, we are also going to provide to our customers the SLA-based solution that we can support our customers and create their product. So that's the entire story, that how we are working together, how we are collaborating, and how we are helping the ecosystem. Now, when we are trying to do the project needs a lot of features or a lot of secret sauces that every customer or every platform manufacturer wants to put. And in the beginning, I mentioned that innovation is one of the particular subject. of open source. How are we enabling the industry or the ecosystem to innovate more? So we layered this approach such a way that at the bottom, if you see, there is a Linux Foundation OpenBMC. That's exactly the same thing that we are contributing back, and we are enhancing that together with Intel. On top of that, we have some platform level code, which will be available for the OCP accepted platforms and OCP inspired platforms. And then we have our AMI Kickstart. So all three together is a success recipe for open edition of our Mega Rack, which is a Mega Rack OE, which is the OCP contribution. On top of that, there are some Redis blocks, which are IPs that we bring to the table for making products on top of that. And those are AMI value add, could be AMI utilities. There are enhanced utilities to make this project easier. And then there are some expansion packs. Then silicon providers also provide the silicon IP on top of it. And now this is completely separated in a way that our customers can write their own customer-specific IP on top of it. And they're free, and that freedom we bring, that you can keep your IP to yourself, you can develop freely, and it can be developed independently. So that's why we believe that this open source will bring freedom to it, freedom to all of you. And this portion of the IP is maintained and owned by the customers completely. So when we are talking about foundational technologies or foundational firmware, there are three things. One is boot, which is power on. Then manageability, which is BMC that we talked about. And third one is very important in today's environment is the security firmware. Hardware root of trust or platform root of trust. Today, we are very pleased to announce that AMI is contributing today a Tectagon OE Open Edition firmware to OCP. And it is first developed on AST1060, our big partner SPEED today. And saying that, I would like to invite Dwarka Partni from SPEED. He is the VP and General Manager of SPEED to say a few words about our collaboration. Yes, I think maybe there is a microphone I forgot to ask. Or if you can use, okay. Yeah.
All right. Thank you, Sanjay, for inviting us here. And we're really happy at ASPEED that we are able to partner with your open source initiative. And for past several months, we've been working with your team, helping you with this initiative. And good to see all that work is coming out now with the Tectagon OE. AST1060, this is a product that we designed with a lot of help from our customers and partners with their feedback. And this product, we believe, along with the open source initiative from AMI, would help a lot of our customers in enabling their security features, especially at the platform level. I don't have any special details about this, but I'll let Sanjay talk about the open source part of it.
Okay. So at the right-hand side, left-hand side is that AST1060 block diagram that you are seeing, and we implemented the hardware root of trust firmware on top of that. What we are contributing today, we are contributing a framework, and that framework will enable the ecosystem today to develop on top of it really a good platform root of trust. So what are the layers that we are contributing? We are contributing a hardware abstraction layer. What does it mean? This is also to enable all other controllers or any other silicon to play the same role of platform root of trust. On top of that, we have a silicon enablement code which is coming from SPID today, and that could be other controllers and other FPGAs or any other implementations. Then we have an EMI middle layer which is going to be separating or abstracting the actual security APIs or higher level APIs. Today we are contributing Cerberus, which is first introduced by Microsoft. It's an open Cerberus specification, but in the future we'll be actually can publish any other security protocols or any other higher level security APIs. On top of that, we have a platform independent hardware root of trust operations and hardware root of trust application layer, where the applications can be developed on top of that. Based on a state machine architecture, easy to extend and easy to add innovation or IP blocks on top of it. So that is what we have contributed today. And we are only 3 minutes left, so perfect time. Call to action is, I would say only community, community, community. So let's build a community, a robust community. So there are the 3 source code link for all 3 platform foundational firmware source code. I would like to invite you to our booth, A14, I believe. And we are showing a lot of demo on the open source, partnering with a lot of hardware manufacturer as well as silicon vendor, silicon partner. You can see the actual demo of the AST1060 open source Tectagon OE. So let's build a robust, solid ecosystem on open source. And thank you all. That's pretty much from my side. Thank you.